Okay, good afternoon, all of you. My title is Application of Calotropis procera based chelating resins for the pre-concentration and estimation of iron, nickel, and copper in milk, cereals, and vegetable oils. Proposal and hypothesis. Preparation of chelating resins from the wasteland desert plant Calotropis procera, that is commonly known as Acar acra. The characterization investigation of various parameters on the absorption of metal ions by batch and or column method. Development of methods of trace estimation of ferrous, nickel, and copper ions, and the application of cereals and vegetable oil. Abstract. Three novel chelating resins, that is modified Calotropis procera dry latex, modified Calotropis procera bark, and modified Calotropis procera root, have been prepared by the different parts of the Calotropis procera, that is latex, bark, and root. The method of preparation of resins and their analytical prospects are also delineated in my research work. The effects of various parameters on the absorption of metal ions has been evaluated by batch and column method. The method of trace estimation of ferrous, nickel, and copper have been developed and successfully applied in their estimation in the samples of milk, cereals, and vegetable oil. The general introduction and necessity of this research work. Environmental monitoring of heavy metal ions plays the most significant role in ecological assessment and to understand the dissemination of pollutants. Heavy metal ions exhibit toxicity even at low concentration, so that their accurate estimation is essential. Copper, zinc, bismuth, nickel, selenium, etc. are very important for living organisms. They can be vital or toxic for the concerned organism depending on their concentration. The accurate analysis of metal ion is one of the most concerned area of the research. In analytical chemistry, one of the most difficult and complicated tasks is the accurate analysis of metal ion, especially at trace level, as there is meticulous requisite of versatility, specificity, sensitivity, and accuracy. Present scenario. Today's various techniques are available for the direct determination of trace metal ions. The solid phase extraction of metal ion has the clinched swift acceptance over other methods owing to several advantages. Now, what are the chelating resins? A group of materials having chelating or complexing group embodied on their surface are known as chelating resins. For example, Dovex, Chelax, Sinex, Ambalite, Cellulose, Starch, etc. Now, for specific and selective absorption, above material can be used as support matrix. For example, iminosalicylate silica, which is the chemical modification of a resin surface, that is silica, with salicyl aldehyde or orthovinylene. Now, as you can see in the picture, the hydroxy group present on the surface of the silica has been anchored by the 3-aminopropyl trimethoxysilane. So, this anchored ligand or pennant ligand can be used for the selective absorption. Application and advantage of chelating resins. Extraction of metal ions without using toxic chlorinated organic solvent, high capability of binding metals, high selectivity, thermal stability. The advantage of green resins and disadvantage of green resins and disadvantage of chelating resins and the need of green resins. Method of preparation of almost all involve the use of toxic solvents. The synthesis procedure is tedious and time consuming, and the preparation of, for example, the preparation of immobilized silica requires 72 hours. These methods are very expensive and in many cases regeneration is not possible. These are the techniques which we have used in our research work, that is spectroscopy and chromatography. Now, synthesis of modified Calotropis procera resins, it includes following steps: identification and collection of plant material, preparation of dried powdered material from the different part of Calotropis procera, cyanogen bromide activation of powdered Calotropis procera, immobilization of amino alkyl group on the activated powdered Calotropis procera, synthesis of modified Calotropis procera. These are the pictures: plant, collection of the sample, and the prepared resin. These are schematic representation of various reactions, that is cyanogen bromide activation, immobilization of aminoethane, conversion of aminoethane into N-salicyl aminoethyl Calotropis procera dyed latex. Now, the table presents the characteristic IR band of aminoethyl and modified Calotropis procera, latex, bark, and root. For the trace estimation of metal ions, we have used batch and column method. The optimization of working condition. For the optimization of absorption time, we have used batch method, and the supernatant solution was separated off at different time intervals for between 2 to 20 minutes, and the solution was determined by the means of AAS. As you can see in the table, for equilibrium absorption time for ferrous and nickel is 8, and for copper it is 10 minutes. The absorption isotherm, again batch method is used, 6 sets have been prepared between the range of concentration, pH was maintained, and supernatant solution was determined by the AAS. Absorption isotherm values are also given. Now this is the graphical representation of absorption isotherm of ferrous, nickel and copper. Effect of pH. To investigate the effect of pH, we used column method, and the flow rate was maintained 2 ml per minute, and evaluation was carried out by 0.1 normal HNO3, and the estimation by AAS. The effect of pH. The optimum pH for the investigation of ferrous is 6.5, for copper 7.0, and nickel 6.0. These are the graphical representation of data. The effect of type and the amount of immobilized resins. For this, we have used column method, 3 different immobilized resins, that is Polytropis procera, bark, root and dry latex. The particular amount of the latex, that is from 0.02 to 0.16 gram of modified resins. Flow rate was 2 ml per minute, and evaluation was carried out by 0.1 normal HNO3. As you can see in the table, the Calotropis procera dry latex is better as compared to modified bark and root. In the case of Calotropis procera dry latex, we are able to recover 100% metal ions with using 0.08 gram of the resin. This is the graphical representation of the data. Effect of temperature. To investigate the effect of temperature, we have used batch technique. The solution were kept at constant temperature between 25 degrees centigrade to 45 degrees centigrade in a thermostat. Supernatant solution was separated off and determined by the means of pH. The absorption increases up to 35 degrees centigrade, it becomes constant up to 45 degrees centigrade, and then it decreases marginally. The effect of flow rate was also investigated by the column method. The most suitable flow rate found is 2 ml per minute. The effect of electrolyte had no effect on the absorption of metal ions by the immobilized resin. The pre-concentration and recovery of metals, as you can see, we could able to recover 98.7% of Fe, 97.5 of copper, and 98.4 of nickel. The analytical applications of immobilized resin. By applying using these resins, we could able to determine the iron in milk. These are the data. We could able to determine the irons in medicines tablets. These are the data from cereals, and determination of nickel in partially hydrogenated vegetable oils. These are the tabular representation of the data, and the determination of nickel in hydrogenated vegetable oils, that is ghee. These are the data. Now conclusion. Immobilized resin is quite effective in the pre-concentration of ferrous, nickel and copper. The working conditions are easy to manipulate and the methods are very selective. Iron and nickel have been successfully estimated in various commercial samples. The immobilized resin can be used and the method is green. No chlorinated solvents are needed for the extraction of these metal ions. The acknowledgement, Green Chemist Research Center, Government Dunga College, Bikaner, College of Engineering and Technology, Bikaner, and UGC for financial assistance. Thank you so much.